Welcome to Spring LIB.
Now, the Tarzan on the swinging vine, with or without the chimp, is the case of a simple pendulum. The Tarzan first comes to rest after beginning his swing at the end of one half of the cycle. So, time period, that is capital T, is equals to 8 seconds, that is given. Now, when we apply the conservation of linear momentum to find the speed and kinetic energy of the system just after the Tarzan has grabbed the chimp. Now, we have considered h to be the height above the lowest point of the swing, and now h equal to L into 1 minus cos theta. And we also know that the time period of a simple pendulum is 2 pi root of L by G. So in the A part, we have to find out the time period. So 2 pi root of L by G is there, and L is given by G of T by 2 pi the whole square. So when we put the value of L, we get 9.80 meter per second square, that is acceleration due to gravity. Time period we have got 8 seconds upon 2 pi the whole square, that equal to 15.9 meters. So this is the length, 15.9 meter, or approximately you can tell to be 16 meters. Understood? How did we do? First we took the formula for time period and then the length. Now, the second part, B part, frequency equal to 1 upon t. That equal to 1 upon 8 seconds. That equal to 0.125 hertz. If this is the frequency, the amplitude would be 12 degree. Now the next part. When we apply the conservation of energy to find Tarzan's speed just before he grabs this shrimp or chimp, U1 equal to K2. So when we equate that, we get mgl into 1 minus cos theta equal to half mv squared. That is potential energy equal to the kinetic energy. That is the conservation of energy that we have. So from this, we get the velocity to be root of 2gl 1 minus cos theta, and equal to, we are putting the values, 2 into 9.80 into 15.9 that we had got of L, 1 minus cos 12. Theta is 12 degree that we have. So this will give you the answer. When we calculate, you will get 2.61 meter per second. Now, when we apply the conservation of momentum to the inelastic collision between the Tarzan and the chimp, we get 65 kg into 2.61 meter per second equal to 65 plus 35 kg into capital V. which gives, after we calculate it, we are getting capital V to be 1.70 meter per second. Now again, we are applying the conservation of energy to find the maximum angle of the swing after collision. So to find that, you have to see again the conservation of energy formula. And that is half m total capital V squared equal to m total GL 1 minus cos theta. Now solving for theta, it gives 1 minus cos theta equal to V square upon 2GL, and putting the values 1.70 upon 2 into 9.80 into 15.9 we have, and that is equal to 0.00927. Hence theta equal to 7.8 degree. Okay, so this is the theta that we got. Now frequency we know, that is equals to 1 upon 2 pi root of g upon, why is it? Because frequency is equals to 1 upon t. Now the length doesn't change. Here the length is not changing. So f remains to be 0.125 hertz. Because L doesn't change and all the others are constant. F doesn't change. It remains to be 0.125. And F doesn't depend on the mass or the amplitude of the swing. Because F doesn't depend on the mass and amplitude, F doesn't change. Now, since the amplitude of the swing is fairly small, we can use a small angle approximation for which the period is independent of the amplitude.